This is assignment 4. We're asked to make functions to do byte-oriented RLE, encoding and decoding using ASCII characters on a fixed buffer size. So the program is meant to compress a string, print the original string, and then encode it. Once encoded, it should print the output of the encoding function and its length, then print the decoding function's output and its length, and there should be a message to the user if a string is unable to be compressed. So in order to start, we need to go into our rle.h header file and list our functions. So we have 4 functions. The special characters function, which checks for special characters. If a special character is found, it'll signify that the string is invalid and cannot be compressed. We have the encoding and decoding function, which uses char pointers to look at each ASCII character in the string. And then we have a print function, which will be used in the main file to print the results. So now we can go into our rle.c file, which is where the implementation of our encoding and decoding functions are. So to start, we know that the assignment says that the buffer should be 500 characters, so we need a constant. So here we define max r length, which is 500, which means that the string being encoded and decoded cannot be anything more than 500 in length. Then we can get into our functions. So our first function is the special characters function, which is a function that checks whether the string is valid or not. So in order to do this, we can declare our variables, and we know we need a counter for our for loop. So we declare I. We also declare a variable called flag, which equals 0. So in the for loop, we can check each character of the string for special characters. If one is found, we can return flag, which is 0, signifying that the string is not valid. If no special characters is found, then we can return 1, which signifies that the string is valid, and we can continue with the encoding and decoding of the string. The next function we can write is the encoding function. It returns the run length encoded string for the source string src. So to do this, we need a for loop. This for loop will traverse the input string one by one. So in the for loop, we're copying the first occurrence of the new character in destination, and while we go through a run, our length is being incremented by 1 each time an occurrence has been detected. So it's being incremented by 1 every time a new character repeats. We also need to count the number of occurrences of the new character, which is copied in destination. So we create a while loop so that our length is stored in a character array called count. Then we can print the encoded string using the sprint function. And this for loop copies the count array to destination. So because we are working with multiple characters, we need to determine when a run ends. In order to do this, we can terminate the destination string by placing a null character at the end and then return destination, which returns the encoded word string back to the main function. So now we can write our run length decoding function. So here we need a for loop to go through the string and check every ASCII character. If an ASCII character is found, we need to convert the integer in character form into an actual integer. This is what count equals I plus 1 minus 0 does. The for loop stores the character in an OP character array at the starting position, and then it increases the index of the position by 1. So OPK terminates the destination string by placing a null character at the end, which specifies the last character of the variable that was decoded. So then we can print the decoded string and return the decoded string back to the main function. So for our print function, we are using a pointer to go through a while loop to go through the string. So if the string is greater than the max run length, which is 500, then we can print the string that the string cannot be compressed because it exceeds the length limit. So here we called our special character function. In the special character function, if no special characters were found, we can can continue with the encoding and decoding by calling both functions. So both the encoding and decoding functions use a while loop and a pointer to find the length of both outputs by incrementing the positions of the pointer and keeping track of how long the output is. Then we can print the respective lengths in the output. So we have an else statement when the special character was detected, meaning the string cannot be compressed. Then we can print the message to the user. And finally, we can write our main function. So in order to hard code different cases to display different scenarios, if-else statements were used. So in a for loop, we can loop through each case to be performed. So in each case, a string is set, then printed. Then the print function is called, which performs all the encoding, decoding, and string testing. So now we can run the code. As you can see, in the first case, the string is valid. So we print the original string, print the encoded value, the length of the encoded string, the output of the decoded string, and its length. We know it's correct because there are 9 H's, which is H9, 9 D's, which is D9, and so on. And for the next case is when the string is larger than 500. Here you can see a message is printed saying the string cannot be compressed because it's larger than 500. And in the final case is for special characters. So another message is printed saying that the string cannot be compressed due to finding special characters. And that is assignment 4.